Hello everyone, welcome back to Maths by Gurpreet Sekho, where maths is made easy by me and I hope it becomes easy for you guys as well. So we've been doing the triangles chapter of class ninth from NCERT book, and so far we have done our first congruency criteria as well as two examples related to that. Today we'll be doing our remaining criterias as well as the remaining example of our first exercise. Okay, so firstly the criteria that I'm going to discuss is ASA congruence rule. Okay, yesterday we discussed SAS rule, and A means angle, S side, and another angle. Okay, now what does this rule state? It states that two triangles are congruent. So suppose there are two triangles, that is ABC and DEF. According to ASA congruence rule, these two triangles are congruent if and only if two angles, that are angle BE, angle CF, are equal to each other, and the included side, now which is the included side? Of course BC. BC is equals to EF. If two triangles are satisfying these three concepts or these three criterias, only then the two triangles are known to be congruent to each other. Okay, so what does it mean? That angle B must be equal to angle E, and if angle C also becomes equal to angle F, and the included side BC, if it's equal to EF, then our two triangles will become congruent to each other. That is triangle ABC congruent to triangle DEF. Okay, this is what this criteria states. Now here is the question that there is given proof which is quite lengthy and it's in your book. I don't think that it have greater chance of coming there in your exam, but if you still find any problem, because it's very easy, you can give one read to the proof of ASA congruency rule, and if you find any query you can DM me on my Instagram ID which is given in the description, and you can also use the comment section to share your queries with me. I'll be more than happy to assist you there. Right, so this was about ASA congruency rule. Now we are left with only one congruency rule, that is AAS congruence rule. So let's discuss that as well. Now the next one here is AAS congruence rule. Okay, now you must be wondering that just we have discussed ASA, right? And what is the difference? Because here it's also two angles and two angles, one side and one side. Now the difference lies in the fact that, again, consider two triangles, that is ABC and DEF. Okay, so ABC and DEF. AAS states that if two pairs are equal, for example, angle B is equals to angle E, angle C is equals to angle F. Okay, if two pairs of angles are equal, then according to ASA, the included side must be equal, that is BC must be equal to EF. Only then the triangles will be known as congruent triangles. But according to AAS, if two pair of angles are equal and one pair of corresponding sides are equal, then the two triangles will known to be congruent triangles. Now it means that, for example, AB is equals to DE and two angles and one corresponding side is equal, one corresponding side, okay, the pair of one corresponding side is equal, then also the triangles are known as congruent triangles. So this is the basic difference. That is why S is included between two A's, because it means that the included side, but here S is at the last and two angles are combined. It means two angles and any other third side must be equal to each other of two given triangles. Then also the triangles can be treated as two congruent triangles. Just learn this difference because it will really help you, because most of the times students just try to prove that only the included side is equal, like they only try to prove that BC is equals to EF. But instead you can also prove that AB is equals to DE or AC is equals to DF. Then also the triangles will be known as congruent triangles. All right, now we are done with two remaining congruency rules, and we are only left with one example. So just let's do that example and let's finish the first exercise of triangles. This is the third example and the last example of first exercise 7.1. Now in the statement it's given that AB is parallel to CD, two lines are parallel, and O is the midpoint of AD. O is the midpoint of AD. It means OA will be equal to OD. Simply, it's not written but it's automatically understood. And we have to prove that triangle AOB is congruent to triangle COD. Yeah, so firstly we'll make the portions of the triangles equal which can be equated. Okay, so firstly, as it's given that O is the midpoint of AD, it means OA is equals to OD, right? It's very much clear. We can write the reason here as it's given already, because OA is equals to OD. Now after that, we have proven that one side of these two triangles is equal. Now we can shift towards angles. You can clearly see that there are two angles, and what this pair is known as, yes, you are right, vertically opposite angles. So very easily angle AOB is equals to angle COD. Don't forget to write the reason that these angles are vertically opposite angles. Okay, so yeah, one angle and one side is already equated, and both are coming out to be equal. Now one angle is remaining. Now we have done an example in the previous video, in yesterday's video, in which I just produced this line and here as well, and this can be treated as the transversal. AD can be treated as the transversal. So if you are unaware of the concepts of transversals and parallel lines, you can go and watch the video. The link of the video is given in the description. It's of lines and angles chapter of the same class, of 9th class only. Okay, so yeah, you can go and watch that video, and then you can clear your concepts of transversals and parallel lines. So this is given that these two lines are parallel lines. So what is the angle? What is the angle? Alternate angle. We have to see that what are the alternate angles here. It's of course ABO and DCO. If you want to take the transversal CB, you can take that as well. If you want to take the transversal AD, you can take that as well. In your book they have taken BC as a transversal, but we can take AD as a transversal as well. So if we want to take AD as a transversal, then of course the angles OAB and ODC will be equal, and if you take BC as a transversal, the angle ABO and angle DCO will be equal. So it's totally up to you. So now we can clearly write that angle OCD or DCO is equals to angle OBA, right? Why? Because these are alternate angles and these are equal, but only for parallel lines. Alternate angles of parallel lines. What are the lines? AB and CD. All right, you have to mention reasons simultaneously as well. Only then you will be able to score good marks in geometry. Okay, so now we had to prove AOB is congruent to DOC. Yeah, so one side angle and angle. Okay, so by AAS rule we have proved that triangle AOB is congruent to triangle DOC by AAS rule, because two angles and one side are equal. Okay, so first part is proven. What is the second part? That is O is also midpoint of BC. We have to prove that O is midpoint of BC. It means OC is equals to OB. Yeah, this is what we have to prove. Now we have already proven that these two triangles are congruent, and in the previous video I have told you the concept of CPCT, right? So now these two triangles are already congruent. It means the remaining side, that is OC, will automatically be equal to OB, because these are the sides, the remaining sides of two congruent triangles. So by CPCT, we can easily prove that OC is equals to OB. So which means O is midpoint of BC. Right, so with this we are done with our very first exercise and three congruency rules. Yeah, there is another rule, that is SSS. It's in the third exercise. We'll be doing that for sure. All right, so this was all for today, and you can start practicing your first exercise, and don't forget to press the subscribe button, as it will really motivate me to make these kind of videos for you on a regular basis. All right, so keep practicing, and don't hesitate in just consulting your queries with me. You can DM me, you can use comment section. All right, so see you in the next video. Keep practicing. Till then, best of luck.